Hi guys, right, in this video we are going to work with double angles grade 12, right, trigonometry. Consider we are given cos 2 theta. So cos 2 theta is a double angle of cos, right? And we have three of them. Cos squared minus sine squared theta, as well as 1 minus 2 sine squared theta, as well as 2 cos squared theta minus 1. So these are the most important three identities. These are the most important three identities. So that we are going to work with in this case. Okay, so we also have a double angle of sine. So that will be sine 2 theta, which will be 2 sine theta, as well as cos theta, in which this can be manipulated to be half sine 2 theta. So for this, which will be equal to cos theta times sine theta, right, when you manipulate it. But without wasting time, let me show you how did we came up with these identities. We'll start with cos. Cos was derived from a compound angle of cos. Remember that, let's say we're having a theta, cos theta plus theta. So this is a compound angle of cos. From a compound angle, we'll derive a double angle. How? Let me show you. From this compound angle of cos, we can get these three identities. How? Let me put this into practice. So the product, this will be the product of cos theta multiplied by cos theta. What happens, remember, since it's a compound angle of sine, the sign changes, so it will be a product of sine theta and sine theta. So what is cos times cos? That will be cos squared theta. Sine times sine, that will be sine squared theta. So we have derived the first identity. Hope you saw how this first identity came from. So let's derive the second one, which is 1 minus 2 sine squared theta. To make life easier, to derive the other, we need to change one of this. How do we do that? You may recall from grade 11, you have learned about an identity of which is called square identity. So it's sine squared plus cos squared, which is always equals to 1. So if you want to make sine the subject, you are going to say sine squared, then take cos to the other side. This will be 1 minus cos squared theta. So if you want to make cos, we are going to transpose sine. So we are going to have 1 minus sine squared theta. Meaning that whenever you see sine squared, you replace it by 1 minus cos squared. Whenever you see cos squared, you replace it by 1 minus sine squared. So what are we going to do? Let's change cos. Remember, when we make cos the subject, we're going to replace it with what? With 1 minus sine squared theta. So let's replace it with 1 minus sine squared theta. Then since we're substituting, we'll put bracket minus sine squared theta. So let's take out the bracket. We're going to have 1 minus sine squared theta subtracted by sine squared theta. We can see from here, guys, we have the like terms. Negative sine squared minus negative sine squared, that will be 1 minus 2 sine squared theta. So this is the second identity. Right, so what about the third one? The third one, it's 2 cos squared theta minus 1. To get the third one, we will change now sign. So this will be cos squared theta. Remember, I told you that whenever you have sine, you're going to replace it with 1 minus. So from here, remember I told you that when we change sine squared, we are going to have 1 minus cos squared. So this will be 1 minus cos squared. Okay, so let's get rid of brackets there. This negative will multiply everything from here. it's a full method. Well, -1 times 1, that will be -1. Negative and negative, that will be positive cos squared theta. The like terms, cos squared plus cos squared, these are the like terms. So cos squared plus cos squared will give us 2 cos squared theta minus 1. So this is how they derived the three identity of cos. Then guys, let's look at lastly, let's look at how did they derive the formula of the identity of sine 2 theta. So consider now an identity of sine 2 theta. Then this will be a compound angle of sine theta plus sine theta. This will be sine theta plus theta. We know that will give us sine 2 theta. So, but let's derive it. This will be the product of sine theta and cos theta. Remember, it's a compound angle of sine. Sine do not change, so it's still going to be plus. So we are going to have cos theta as well as sine theta. So what happens here, we have like terms, guys. We have like terms. So since they are like, so we are going to have 2 sine theta as well as cos theta. So this is how they derived these formulas, right? So now we are going to look at the application of it. We'll look at few examples that will help us so that we tackle exam questions and work with proofs, guys. Right, let's put this into practice. Simplify without using a calculator, or we could say simplify without using a calculator. Cos squared 75 plus sine squared 75. Remember, that reminds us of cos squared theta plus sine squared theta, which is a special identity. So we are working with a special identity in this case. So that will be 1 actually. The solution will be 1 when we're given cos squared plus sine squared 75. Right. So what about cos squared minus 75? What about cos squared 75 minus sine squared 75? Remember, it reminds us of this identity of cos, which is cos 2 theta, which will give you cos squared minus sine squared theta. So this part, so in other words, it will be cos 2 multiplied by 75. So that will give us cos 2 times 75, that will be 150. So we have to reduce this. So we have to reduce it. How do we reduce it, guys? To make life easier, since it's cos 150, we are going to say 180 subtracted by 150. What is that? I think that gives you 30. So then when you say 180 minus 30, that will give you 150. So in other words, it's the same as cos 180 minus 30. Which quadrant is cos? How is cos at the second quadrant? Cos at the second quadrant, it's negative. So we are going to have negative cos 30. So since it's a special angle, it will be negative. Let's put this. Punch it. Oh, it's a special angle. It's fine. That is easy. Negative root 3 all over 2. So that will be the solution in this case. Then we are done. Let's go to the second identity. The second identity, we're given 1 minus sine squared 75. Are we using a double? Are we using a double angle of sine or cos? Some may say we're using a double angle of sine. No, it's for cos. Why? What do I mean? It falls under cos 2 theta. 1 minus 2 sine squared theta. So similar. So 1 minus 2 sine squared theta will be cos 2 theta in this case. So we are going to have cos 2 times 75, which will give you cos 150. So it's similar to this. It's similar. we can see it's similar to this, so meaning that we will have cos 30 here. Cos negative cos 30, so we're going to have negative root 3 all over 2. Right, so it's the similar answer. Right, so what about our last question? We are given cos 75 and sine 75. From the double angle of sine 2 theta, we can see that we have 2 sine theta cos theta. So actually it's a half of this. It's a half of this. So in other words, we're having something like this. Half of sine 2 theta will give us cos theta and sine theta. So we will have this here. So you shall plug this here. So we're going to have half sine 2 times 75. So from here, guys, we could say half. So we know that 2 times 75, that will give us sine 150. So we have to reduce this, guys. We have to reduce this. So we're going to have sine 180 minus 30. So that would give us 150. So which quadrant? It's a home for sine, actually. So we're going to have half sine 30. It's a home for sine, so it will be positive sine. So we're going to have half. So sine 30 is a special angle. So already we know that it will give us half, actually. So it's going to be 1 over 2 times 1 over 2, which will give us 1 over 4. So this is how you can apply a double angle. So our next video will be about proofs. How do we apply a double angle of sine and cos when we are working with proof? Hope you find this video useful, and don't forget to subscribe and like. Remember, we